So students, dy by dx is called the differentiation of y with respect to x. Okay, this dy by dx is called the differentiation of y with respect to x. Okay, that means the rate of change of y with respect to x. Okay, so if geometrically, if I am going to plot the curve between the variable x and y, then the curve is looking like this. This is a horizontal axis for independent variable. Here independent variable is x. This one is for the dependent variable, that is your y, and suppose this is your curve of dy by dx, and here I am taking the one point P. So if I am just drawing here the tangent on this point P, okay, so this coordinate of this point P is x comma y. So for a very small change in x and y, we are representing by dx and dy here. So suppose this one is the theta, so tan theta is equal to perpendicular upon base. So that means here it is dy upon dx. This distance, this height is dy, and this distance is dx. So tan theta is equal to perpendicular upon base, so it is dy upon dx. Okay, there are some other differential coefficients of some simple function. Y is equal to x to the power n, dy by dx is equal to nx n minus 1. If y is the constant, then dy by differential of y is 0. So there are so many some other differential coefficients that you have given in your book, that before the starting of this chapter 2 you have to learn, you have to understand all these things. Okay, now I am coming on the two different topics of differential coefficient. The first topic is differential coefficient of product of two function. Okay, differential coefficient of product of two function. Okay, product of two functions. Let us assume the two functions are f1x into f2x. So two functions are here, f1x into f2x. Okay, now the differential of this equation dy by dx, so dy upon dx is equal to first function d by dx of second function plus second function d by dx of first function. Okay, that means f1x d by dx of f2x plus f2x d by dx of f1x. Okay, again see, if there is a product of two functions, so y is equal to f1x into f2x, so dy by dx is first function d by dx of second function plus second function d by dx of first function. That means equal to f1x d by dx of f2x plus f2x d by dx of f1x. So this is the first part, differential coefficient of product of two function. Now the second part is here differential coefficient of quotient of two function. Okay, the second part is differential coefficient of quotient of two functions. Again, we just assume that two functions are f1x and f2x, but it is like f1x upon f2x. So it is a numerator, so I can write when this one is like this. It is a denominator, so I am writing it like this. Okay, so now dy by dx. Okay, we are doing the differential of this y, so dy by dx is equal to denominator d by dx of numerator minus numerator d by dx of denominator and upon square of denominator. Okay, like this. Suppose let us we are taking the one example, the y is equal to, that is example I am taking it here, y is equal to, it is sin x upon x square. Okay, then differential of this, it is dy upon dx, that is means first denominator, then d by dx of numerator. So denominator is x square, so we will like this x square d by dx of numerator here it is sin x, then put minus sign, then numerator and d by dx of denominator. So denominator is x square, so we are writing it is x square upon square of the denominator, and it means square of x square. Okay, so sin x, differential of sin x is cos x and differential of x square is 2x. So differential of x square is sin x is cos x, so it is to become x square cos x minus sin x, and differential of x square, it is x to the power n. So differential of x to the power n is nx n minus nx to the power n minus 1. So it is coming 2x upon x to the power 4. Okay, so it is x square cos x minus sin x, 2x upon x. So x we can take common from this. Okay, so it is coming here, x is common, so it is coming x cos x minus 2 sin x bracket close upon x to the power 4. This x and this power will be cancelled here, so it is coming x cos x minus 2 sin x upon x cube, x cos x minus 2 sin x upon x cube. Okay, so in this topic of differentiation, you have studied what is the means of this differentiation and how we can calculate the product of the two function and in the quotient of two functions. Okay,